Okay, in previous class, we have completed these two small topics, that is the convergence of IT and OT. It means combination of IT team and OT team, both together, if they work, uh, both of these two teams will be succeeded along with the success of IoT. In fact, IoT forces these two teams to work together. Okay, so these things we have studied, and we have also studied some IoT challenges. Some 5 challenges we have studied. First one is scale due to the large number of devices daily connected to internet. The network size is also going to be keep on increasing. Then security and the privacy we have studied. Then big data and data analytics. Then we have also seen the last challenge, that is interoperability. Okay. Now today let us move to next topic. That is a very important topic: IoT network architecture and design. Actually, before going to this actual IoT architectures, network architectures, so first today just I want to give a brief introduction about these architectures. Then we will go to actual architectures. Two types of architectures will come for this IoT, and also one simple IoT architecture is also there. Okay, so before going to that, first we will see this one introductory topic, that is IoT network architecture and design. Just today, just I give you introduction. Okay, so even though you feel this topic is somewhat general, but it is very important for you to understand the next upcoming architectures. And since you are in already final year, within some 3 to 4 months, you may join any company. There, what all the designations will be there, and what is the power of those designations. So what are the high demand designations nowadays? What are the demanding jobs nowadays? What are the jobs which are in demand? So these are also somewhat some points I am going to cover here. So because of that only, I don't want to run this topic. So see, suppose if you want to design, if you want to construct your own house. Okay, if you want to decide to build a house for you, so first what you do, suppose if you go to a hardware shop and you will purchase all the material there, construction material. Okay, it may be timber, it may be bricks, sand, so many things are there. Okay, screw, nut, bolt, everything, cement, all those materials you will purchase, and one truck will come and it will unload your all materials in your site. Okay, where you are planning to construct your house. Then after taking these all materials, so what you do, you cannot directly start your construction of your building or your house, right? So first, before purchasing these all materials, actually you had to you had to approach one architect or one engineer, right? So without contacting him, without taking a proper advice from him, you have directly purchased the materials. Suppose if it is a scenario. Okay, so here what you have done, you have missed one important thing, that is you don't have a architectural plans. It means simply you purchased your all construction materials. Then you are thinking how to do with these all materials, what to do with these all materials. Instead of doing that, first you have to meet an architect, and he will prepare a blueprint for your house. He will plan it properly. Okay, then he will make a estimation and budget. Then he will make a list of materials and quantity of materials. Then you could purchase the material, right? This is actually what we will follow. So here, unfortunately, what happens? Your plans to build your house, beautiful house, you'll have to wait until you get the help from the architect. Correct? So until and unless you don't approach to an architect, you cannot build a house. Correct? So then, to successfully complete your construction project, so time and efforts are required. Of course, it takes its sweet time, and the efforts are also required to design each phase of your house. Each phase of your house means what? First we will complete the foundation, then we will start to construct the walls, then we will put the windows and doors, then we will put the roof. From each and every phase by phase, with the proper plan and with the proper design, we complete the construction project. Okay, so your plans, whatever the architect's plans or your plans, both you can share your plans according to your plan only. That architect will design the blueprint. Okay, so your plans must include the detailed design for the electrical, where all these wirings should be in your wall or in your room or in your, where all the electric points should be there, and plumbing planning. Okay, so heating planning and security systems. So everything in your design means what, in your plan means what, in your plan these all details should be present there. It should not be incomplete, it should be complete. It is a proper and complete design. So here some strong architectural building blueprints are necessary now. So proper blueprints are necessary in all construction projects, even though it is a small house to a big shopping mall, or it may be a big cinema hall, or it may be a big uh, uh, stadium. Okay, whether that construction is that construct that building is small or big. So strong, correct, proper plan and designs and blueprints should be present there. In the same way, here also in our computer network also, before constructing any network, we should have pre-plan. Okay, so how it is we will see now. So in the same way, a computer network should never be built without careful planning. Which network? I am talking about CN, that is computer network. Before constructing a or establishing a network, computer network, we should have a careful planning, and we should take care about security policies here, because there may be sensitive data which is going to be transferred from one computer system to another computer system through this computer network. So because of that only, not only connecting the computers is a big task, along with that, having a security policies is also very, very important here, since there is a sensitive data may be transmitted from the systems through this network. Okay, and we should follow some design, well understood design practices. Okay, so in this, suppose if this network fails, what happens in a company? One computer network is there, all computers are connected. So in that company, if a network fails, what happens? Company all operations will be stopped. Okay, then just as a house must be designed with the strength to withstand potential natural disasters, whenever we construct a house, we simply don't construct it without any plan. We plan it properly, even though any heavy rains, any disasters, any earthquakes, okay, any flood comes there. So that building, that construction should tolerate these all natural disasters. That way, we construct that house very strongly, right? Here also, we should give so much security, so much strength to our computer networks. I hope you are understanding. I am just comparing our civil engineering with our computer science engineering. Okay, so here, due to this natural disasters, our house may collapse. So to make our house strong, we should have a proper design, proper plan, and proper strength in the proper blueprint to construct our house. So similar, in the same way, in IT department also, IT systems, information technology systems need to be designed to withstand or to tolerate the network earthquakes. See, the word is a very beautiful, network earthquake. It means earthquakes are not only affecting the civil constructions, it is also affecting the IT systems. Actually, that is not affecting. Here just simply we have taken this word here, network earthquakes. Network earthquakes is nothing but here some failures. So instead of using that one, here author has used this word, network earthquakes, such as what type of failures we get in IT systems? Distributed denial of service, very, very important attack. It is very dangerous attack. Distributed denial of service attack. Okay, so then future growth requirements and the network outages and even human error. Sometimes human programmer also can do mistakes, right? So these type of all mistakes, this type of all disasters we should avoid. Okay, where in IT systems. So to avoid these all disasters in IT systems, we should have a proper plan here. So to address these all challenges, these all are challenges only for us. The art of network architecture has gained a tremendous demand nowadays. Network architecture. So who build the network? Okay. So who construct the network? It is just like a art. It's a it is art of a network architecture. So who knows this very well? Who know how to construct the network? So for them nowadays there are huge amount of demand is there in IT. Okay. So that only I am telling you now. So they gain a tremendous demand or influence in the IT organizations or in IT companies for past 2 decades. So that is of course last 20 years. These network engineers have a lot of demands. Then in fact for many companies, the responsibilities of overseeing or looking into or maintaining into this network architecture is seen as one of the most senior position. See, because of that only I started this topic from this introduction part because so this is the importance of network engineers. So maintaining the network architectures in a company, so it is also not a small job, it is a heavy responsibility job. Okay. So responsibility of this maintaining the network architecture is also one of the most senior position in a IT companies nowadays. Okay. Not only in IT as well as in other team was there, no, as I discussed in last classes, that is OT teams, operational technology, OT teams also in the organizations. So for example, sir, how these senior positions are available in IT companies. So for your just idea, I am going to tell you one designation is there, that is uh, Chief Enterprise Architect. Chief Enterprise Architect has gained so much traction in recent years that the position is often it is equivalent to the responsibilities of a CTO. It means that CEA designation is not a small designation. It is equivalent to CTO. It means the responsibilities of CTO is equivalent to CEA. What is CTO? Chief Technology Officers. Technology Officer. Sometimes CEA is very closer to CEO directly. CEO is Chief Executive Officer. Okay, Chief Executive Officer who is the head of the company. So he is very close to CEO and he is in direct contact with the CEO. He will direct he will directly report to this CEO. He will directly communicate with this CEO. That much higher position it is, CEA. Okay. So here the responsibilities of CEA is equivalent to CTO, and many times CEA reports directly to this CEO. Okay. So CEO next position will be CEA, that is Chief Enterprise Architect. Okay. So here IT network architecture and IoT network architecture we are going to compare now. IT architecture and IoT architecture. IT architecture, what it has done, IT network architecture has matured significantly. It means it has grown it in its own way. IT network architecture has its own maturity over past some 20 years and is generally already well understood also. But IoT network architecture is nowadays it is recently it has developed. Okay, IoT network in IoT network architecture is recently developed, correct? Because from many years, from 20 years past, we are listening IT, correct? But IoT, we are listening only just few past some 4 to 5 years ago, right? So IT network architectures are so much matured, but IoT networks architectures are very new to the world now. Okay, and they require a fresh perspective. Fresh perspective means they require attention of people. They require a lot of more amount of attention from the people. So it is important to note that while some similarities between IT and IoT architectures, okay, there are some similarities are there, some common things are there between IT architectures and IoT architectures, okay, but there are some challenges are there, okay. So there are some similarities are there between IT and IoT, and also there are some challenges are there for IoT, and also there are some requirements are there for IoT are different from those traditional IT networks. So it means that in IT architecture and in IoT architecture, there are some common aspects are there, or else some similarities are there, but some different challenges are there. IT has its own challenges. IoT also has its own challenges. IT has its own requirements. IoT also has its own requirement. I hope you are understanding, right? So even though there are some common things in between IT and IoT architectures, there are some different challenges and different requirements are there for each of these network architectures. So these the terminology is also different to the point where this IoT networks are under the umbrella of OT. In fact, in this word term IoT, okay, so it is a combination of IT and OT, as I already told you, correct? So here, this IoT networks are under the umbrella of OT. It means this IoT works under the umbrella of OT, that is operational technology team. Of course, it works under IT also. Okay, so it works below this umbrella of OT, which is responsible for the management and state of the operational systems. I already told about this one. OT team is responsible for the management of operational systems. Okay, so operational systems. In opposite, in opposite to this OT, in other way, IT networks. IT networks are primarily concerned with the infrastructure that transports flow of data. IT, IT network primarily concerned with the infrastructure that transports the flow of data. Mainly here, IT network focuses on security of data, which is transferring from one location to another location, from one node to another node. Okay, so it provides completely the secure data transmission. It focuses on secure data transmission. It focuses mainly for the security. IT networks are primarily concerned with the infrastructure that transport the flow of data irrespective of data type. That data may be any type of data. Okay, so here OT is responsible for management and the state of operational systems, and IT is responsible for the transportation of data, secure transportation of data. So both together, if they work, then IoT networks will be also work successfully. Clear? Now, next topic is drivers behind new network architectures. Here, drivers are nothing but here, they are your challenges. They are the boosters. They are motivators. For example, one simple example, if I want to take you, suppose now you are in the final year and you are getting some interviews from your company, and the company has some its own cutoff to get eligibility to give the interview. Some companies expect 70% of aggregate. Some companies expect 65%. Some companies expect 60. Some companies expect just 50 or 55. Okay. So those who are in the range of 50 or 55 percentage of aggregate, they may not get the interview call from the very large MNC companies. Okay, so if they want to increase their result, this is a last chance now. This is the last final semester, and if they really want to get hired in big companies, they want to work hard. Okay, still time is there, and this semester I have only 3 subjects, and if I work more on my project, I may get good marks and I may get first class with distinction, and suddenly my percentage may increase some at least 5 to 6% this time, and instead of 55 I may get 60%. Overall aggregate may be 60%, and my throughout engineering degree will be first class. So I may get hired in a good companies whose requirement is a 60% minimum. Okay, such kind of ambitions, such kind of target, such kind of goals, what you set yourselves to reach that goal, to reach that goal, that challenges whatever they are pushing you, the really trouble, if you are really facing a problem, okay, so that problems will definitely make you to work hard. So these are problems only, we call them as a challenges. So here also I told you IoT is also facing some challenges. In previous class I discussed the same challenges, so we call here them as a drivers. They are taking these challenges, are taking these network architectures to next level. Okay, because the whatever the existing IoT networks are there, they have some limitations. So those limitations only going to be overcome by the engineers. So these challenges are only the main boosters, they are motivators to make our IoT networks so much efficient. So that's only the simple concept behind this topic is that only. Okay, so drivers behind this new network architectures, not old or existing. Okay, so who is the main reason to develop a new network architectures for IoT? That is challenges of IoT. That's all in simple manner. So same example once again I take here, that is using the architectural blueprint to construct a house is similar to approach what we take when designing a network. Okay. So whenever we construct a house, we take a blueprint. Similarly, when we want to design a network, we should have a clear plan, clear blueprint, clear design in our hand. Okay. Now imagine, suppose there is one experienced architect is there who is famous in building houses. Okay. So throughout his career, he has constructed so many number of houses successfully, beautiful houses. Okay. But now he is an expert in this field only, in that area, in that village, or in that city. Okay, and he is well known engineer in that place, and he is knowing exactly what it takes to make that construction architecturally attractive, as well as technically also strong, to avoid or to tolerate these natural disasters. He knows everything about how to construct a house. But suddenly one day that architect got a very good very big opportunity, a project, very big project by somebody. So he is asked to construct. He is asked to construct a big stadium. Okay, that big stadium should be in the city, and it should be in it should be a visit spot or a tourist spot like place. It should be a showpiece of that city. It should be a very famous and beautiful place for of that city, and that stadium can be used for all sporting games, all sporting teams. Okay, and any live concerns or any functions or any community events, for all those multi-purpose stadium, if he is asked to construct, and its capacity should be 60,000 plus. Okay, so if this big project, if he is getting an offer, then what he does actually, see here. So while that architect has extensive experience in designing only homes or small houses, those skills will clearly not enough to meet the demands of this new project. Are you understanding? Because the requirement of a house is different and requirement of this stadium is different, because acoustics and all those things he has to take care in the stadium. But the scale of this stadium is several magnitudes larger than the use is completely different. Of course, the scale of this stadium is different, larger. Constructing a stadium is different, constructing a house is different. Correct? The architect needs new architectural approach now, this time for this new project that meets the requirements of building the stadium. He has to know, he has to learn the new things, architectural things. Okay, architectural approaches to construct this stadium. So here also, if you compare this concept with our IT and OT networks, IoT networks, here also the difference between IT networks and IoT networks is much like difference between this residential architecture and stadium architecture. Because in IT, there were only small number of devices earlier. There were small number of devices which are connected to the computer network, but now when IoT came into the picture, so many number of devices are day by day connecting. The best example is small sensors are day by day they are connecting to the network. So because of this only, IT networks is nothing but it is just like constructing a house. IoT network construction is nothing but constructing a stadium. Okay, so because of make you to understand, I have taken this analogy. Okay, so while traditional network architectures for IT have served us well for many years, they are not well suited to complex requirements of IoT. Even though IT architecture network architectures are serving us still since from last 20 years so very nicely, but still they are not enough for us to satisfy the requirements of IoT, because IoT contains n number of devices. I think when I was uh, explaining you about the computer networks, and I think previous semester or its previous semester when I was teaching you computer networks subject, when I discussed about IPv4 and IPv6, I told you the major difference there. IPv4 is giving us IP addresses, right? So with the help of this IPv4, now all IP addresses are exhausted now. Now, if you want to add still more number of devices to the network, internet, then there is no any IP address to assign to that network or node or your host or your computer or your device. So then what you have to do, you have to ultimately use, you have to transist, you have to transform to IPv6 definitely, because IPv6 if you use each and every sand, okay, if each and every grain of a sand can be addressed with the IP address. So that much clearly, nicely, beautifully that author had explained. I don't know whether you remember it or not. Okay. So with the help of IPv6 IP addresses, we can assign the IP addresses, okay, IP address to each and every grain of sand on this earth. You just imagine how much powerful it is, IPv6, how many number of IP addresses we get. So here, because of this increase in number of things or devices connected to IoT, the one solution is we have to shift from IPv4 to IPv6. Okay, so in previous section, in what is IoT section, in that topic, I discussed some of the differences between IT and OT. Okay, so sir, if I don't remember the difference between IT and OT, just briefly, like a summary, I just once again I tell you here, don't worry. The main difference between IT and OT is a data here. That's all. IT concentrates mainly on the security of data transfer, and OT mainly concentrates mainly on the operations of a systems. Okay, as well as some of the challenges also we have studied. Challenges means which challenges? We have studied IoT challenges. Okay, we have studied the differences between IT and OT, and we have studied challenges, IoT challenges. Okay, these all things we have studied. So these differences and challenges, whatever we have studied, these differences and challenges are only driving the fundamentally new architectures for this IoT systems. Are you understood now? So these differences, these challenges are only making this IoT network systems to go one level up, still up and up. Okay, it means the major reason behind the growth of these IoT network architectures are nothing but these challenges, these limitations, these are the issues, these are the disadvantages. Presently, what this IoT technology is facing, those challenges are only making the engineers to work hard and taking this IoT technology to next level. Okay, so come to this point now. The main key difference between IT and OT is the data. As just now I told you, while IT systems are mostly concerned with the reliable and continuous support of the business applications such as email, web, and database, and so on, IoT is all about data generated by the sensors. So IT is just focusing on secured transmission of data, but IoT is about huge amount of data generation from the sensors, and how that data is going to be stored and how that data is going to be used and who is going to be used that in which way. This is all about IoT. Clear? Therefore, IoT architectures focus mainly on how the data is transported, collected, analyzed, and ultimately how that data is acted upon. It means how that data is used. Clear? And below table, I'm going to show you one table. It is going to show us some differences between IT and IoT networks. Remember, I'm going to tell you the difference between IT and IoT networks. Okay, difference between IT and IoT networks. And also that table will focus on IoT requirements. Right now, what are the existing things are there? Okay, what are the existing components are there in IoT? And still what do we want? Okay, IoT requirements that are driving the new network architectures and considers what are the adjustments are needed, what are the improvements are needed. See here, the challenge, first column is a challenge. The first challenge is a scale. Okay, scale. Its explanation is, description is the massive scale of IoT endpoints. Massive means the huge amount of mm, number of devices, the large scale of IoT endpoints. Endpoints are nothing but here sensors. Wherever I use this word endpoints, you just understand that it is a sensor. Sensor is far beyond that of a typical IT network. So just see here, it means that IT network scale was less. IoT network scale is large or massive. What it means? In IT networks, there were less number of sensors. In IoT, there are more number of sensors. Its meaning is that's only. Okay. Next come to this column, that is IoT architectural change required. What change is necessary now? See, just now I told you, IoT is using IPv4 address space has reached exhaustion. That is exhausted and is unable to meet the IoT's scalability requirements. See, because of n number of huge number of billions, millions together devices are connected to IoT, this IPv4 is not enough now. It is already exhausted. Scale can be met only by using the IPv6. Clear? So now IT networks continue to use IPv4 through these features like network address translation. One more alternative solution it has found now. Then it started to use the network address translation. Okay. Now second challenge is security. IoT devices, especially those on wireless sensors networks, are often physically exposed to the world. So here one disadvantage or challenge of IoT is so devices are directly physically exposed to the world. There is no any security. So less amount of security. Of course, in previous class I already discussed. However, the number of devices or things are keep on increasing. The size of network will be also increased, and the challenge is also increased to provide the security to these all the devices. Right. So here IoT requirement is right now what it requires. It requires a high security, higher security. Security is required at every level of the IoT network. Every level of the IoT network means earlier only security was provided to cloud. Now the security should be provided to each and every level. Each and every level means each and every device should be secured properly. Okay, every IoT endpoint or sensor node on the network must be a part of the overall security strategy, and it must be support the device level authentication. Device level authentication means every device should be authenticated by using some username or password or some security reason, and link encryption. It must also be easy to deploy with some type of a zero touch deployment model. So these are the two main challenges, scale and security. So next challenge is devices and networks constrained by power, CPU, memory, and link speed. So of course here, due to this massive scale and longer distances, the networks are often constrained. In IoT, so n number of devices are there. All those devices should be get a power supply, and they should be connected to the network. So obviously the infrastructure should be very strong, okay, and lossy and capable of supporting only minimal data rates. Minimal data rates means what here? Here, so the speed of that data rates will be in between 10 Mbps to 10 bits per second to 100 kbps. So this is our descriptor. Now, what is the requirement now to make our IoT network very much efficient? New last mile wireless technologies are needed. What is needed? New wireless technologies are needed now. New wireless technologies are needed to support the constrained IoT devices over long distances also. Even though the distance is long, the power supply should be continuous as well as the devices should be continuously connected to the network, and that network speed should be increased. Okay, the network is also constrained, meaning modifications need to be made to the traditional network layer transport mechanisms. Okay, it means its meaning is only so all devices should be powered and all devices should be connected, even though the distance is long distance, the speed of the network should not be decreased, it should be increased only. Okay, the next challenge is massive volume of data generated. See, as just now I told you, IoT, since it is connecting so many number of sensors, they generate a huge amount of data so on daily basis, and they are going to make this network very much busy. It means a bottleneck and slow down those networks. Okay, slow the analytics means they slow down the data analytics in the cloud. Okay, so what to do now? What is the requirement, or what improvement we should do?